Hey guys, welcome to another video. Today we'll be talking about drag. So in the last video we spoke about something which is called as form drag, and now we'll be talking about skin friction drag, or they also call it a drag because of boundary layer and all those things. But today we'll be talking about skin friction drag, right? Before we go into that, there's another concept that you need to understand, which is called as the boundary layer. So on the side, I'm also looking at the syllabus, which is as per DGCA, so that we can cover accordingly, right? There's no point in keeping on covering and not covering the syllabus. So starting with the boundary layer, so it says the first line for boundary layer that it says is skin friction drag is a function of the layer of air closest to the surface. So uh, whenever air is flowing along a surface, what happens is a, a small amount of air. We have already read about streamlined flow and all these things. So a small amount of air will always stick on to the surface, right? Whatever object it might be. Now let's say in case of an aerofoil, when air is flowing across an aerofoil, what happens is a small amount of air is sticking to the surface of this aerofoil, and that is basically the reason for skin friction is basically, let's say, an aerofoil, however smooth it might seem, friction would always be present, right? Doesn't matter how smooth the surface gets, it cannot be always perfect, so there would be always friction between the aerofoil and the air that is flowing along the aerofoil. Now, they're saying that as air flows over a wing, the roughness of the surface and the viscous property of the air itself slows it down, right? So that's what I said. Now, let's say air is flowing along an aerofoil, and in your head, just imagine there are small grooves or small, cracks and all these things which are not visible to the naked eye, but it is there and it is causing friction, right? So that is what is causing, basically, you can say, a boundary layer as well as skin friction. Now, let me also explain to you what is a boundary layer. Now, whenever air is flowing, we already told that we already established, or I already explained to you that when air is flowing along a surface, there's a small amount of air sticking to the surface. So what is happening is, because of this friction, as air flows along the surface, there are these particles of air which comes almost to zero velocity because it is sticking to that surface. And they are also saying at the surface the air particles adhere to it means sticks to it, and their relative velocity is reduced to zero. So basically the relative velocity with respect to the surface on which the air is flowing and the aerofoil, and of course, and whatever surface and the air is reduced to zero. So there are so basically a boundary layer is like a layer that is formed on top of the aerofoil. So the definition goes like this: the boundary layer is the layer of air between the surface and the free stream velocity in which local retardation takes place, right? So basically there's a surface, there is air flowing like this, and there's a layer of air which is almost at zero velocity, and it is sticking to this surface, and that is your boundary layer. Now there are two types of boundary layers. One is laminar boundary layer and one is turbulent boundary layer. Now when it comes to the word laminar and turbulent, we have already explained this. Laminar is basically a streamlined flow, and turbulent is basically a disturbed airflow, right? What is favorable is always would be a laminar flow compared to a turbulent flow. Now, let's look at the definition of a laminar boundary layer. So laminar boundary layer is a very thin layer of smooth airflow. right? It consists of a series of laminations or smooth regular streamlines. So air is flowing smoothly over a surface, and that is your laminar boundary layer. Now boundary layer is, again I'm reminding you, is uh, an a layer of air that is basically sticking to the surface of the aerofoil, right? Now laminar boundary layer would be a very smooth layer of air that would be sticking to the aerofoil, and a turbulent boundary layer is a layer of disturbed or turbulent airflow in which the streamlines break up. So they're basically saying that turbulent boundary layer would be a basically disturbed layer of air that would be above the surface of the aerofoil. Now generally what happens is, as air flows across an aerofoil, it is generally laminar during the start, and what happens is, as it goes towards the end of it, it uh, it becomes turbulent, and that's how it works. Now they're also saying that the boundary layer also increases in thickness as it moves rearward over an aircraft wing. So that's what I said. uh, during during the start of an aerofoil, it is laminar, airflow is laminar, or the boundary layer is laminar, and at the end of the aerofoil, the airflow becomes more turbulent, or there's a turbulent boundary layer, as they call it, right? And they're also saying that as airspeed increases, basically what happens is that the layer of laminar airflow along an aerofoil is reduced. I mean, let's say this is an aerofoil, right? My hand is an aerofoil, and in a normal airspeed, let's say that there would be this much of, from here to here it would be laminar airflow, and beyond this it would be turbulent, right? Now as airspeed increases, what would happen is that the amount of laminar airflow will reduce and the amount of turbulent airflow will increase, right? That's what they say. Now having explained this, let's jump to skin friction drag. And before we jump into it, I want to read the definition to you. Skin friction is a reaction to the retardation of airflow within the boundary layer. So it is the effect of the boundary layer that is acting. In practice, the amount of skin friction depends on the rate at which the air adjacent to the surface is trying to slide relative to it, right? So what they're basically saying is, this is the air, this is your aerofoil, right? This friction, the friction between both of them, is basically your skin friction drag, right? And they are also, trying to explain that, let's say if there are two solid objects that are doing this, I mean two solid objects that are rubbing against each other, there would be something called a shear stress. So skin friction drag is somewhat close to that, right? And there are two factors that they're saying that will affect your skin friction drag. Number one is the effect of speed. So they're saying that as speed will increase, it would cause greater skin friction drag, right? So it's saying the effect of speed causes the transition point to move progressively towards the leading edge with increasing forward airspeed. So we have already spoken about this, because as speed increases, there would be more turbulent airflow and less laminar airflow, and because of which there would be a larger turbulent boundary layer, and this causes more skin friction drag, right? And the second thing that they want to say is the effect of surface roughness. So this is also, so basically what I want, okay, let's get back to it again. Two factors, one is the speed and one is the effect of surface roughness. Now roughness of the surface can also be increased if, let's say, there are water droplets, there is snow on it, there are ice particles. All these things would increase the effect of surface roughness, and more the roughness, more the skin friction drag. So all this put in summary, what you get to understand is skin friction drag is nothing but the rougher the skin, or the rougher the surface, more the drag, right? It is self-explanatory. Secondly, as the speed increases, skin friction increases, right? So these are the two things. It is basically, you can just imagine if there's a layer of air flowing across your skin and your skin is very rough. Now air will find it harder to flow over your skin, right? And comparatively, if your skin is very smooth, air will find it very easy to flow over it. Basically, it is like that. Or basically, if you rub your hand against a rough skin, you will feel more uncomfortable, right? Compared to you moving over your hand over a smooth skin. So that is what they're trying to explain. So hopefully you understood something. Happy landings. Cheers.